We already talked about what it means for a expression to be a function when we look at it algebraically. We said that every one input that you have has exactly one output. But let's see what that actually means graphically. Actually, a lot of times when people see it graphically, it makes a little more sense. So we said a function has, let's see, if you put in exactly one input, you're going to get exactly one output. What does that mean on a Cartesian plane? What does that mean if we talk about a graph of a function? Let's think about the opposite situation. What would happen if you put in one input and get two different outputs? In other words, what would happen if you put in one x value, right? On a graph, usually the x is the input, and you got out two different y values. Okay, so for example, if I put in x equals 2, and I got out y equals 3, and y equals -4. In other words, if on the graph there existed the points 2, 3, and the points 2, -4, we said this is not a function when this happens, whenever we have two y values for any one x value. Well, it actually turns out that it looks, you can see that whenever something's not a function, there's 2 points that are actually right on top of each other, at least 2 points. They're vertical from each other. And actually, if I maybe graph something that looked like this, there are a lot of places on this graph where you could definitely say this is not a function, because if you look at this x value right here, for example, you see that there's a y value that relates to that x value here, and boom, there's another y value that relates to that x value there. There's two y values for one x value, two outputs for one input. So it's actually this pretty simple illustration can really help us to easily see graphically what it means for an equation to be a function. And we have a test for this that's called the vertical line test. The vertical line test essentially says this: if at any point on the graph if you can draw a vertical line somewhere and hit more than one point, then the graph is not a function. So for example, on this graph, I can draw a vertical line right here, and sure enough, I hit 2 points. So this means that this is not a function. This graph is not a graph of function, an equation that's a function. Now the opposite of that is also true. If you can draw a vertical line anywhere on the graph and never hit more than 1 point, then the graph is a function. So something like this. No matter where on this graph that I draw a vertical line, anywhere I go, I'll never hit the graph more than once. So I can say that yes, this one actually is a function, because nowhere where I draw a vertical line will I ever hit the graph more than once. If you think of something, some other basic shapes that aren't functions versus something that is a function, for example, a circle is definitely not a function, because I can draw a vertical line right there and automatically hit 2 points. But something like a parabola is always a function, because anywhere I draw a vertical line, I'll never hit the graph more than once. And even a graph that has a hole in it can be considered a function, because by the vertical line test, you'll never hit it. You might not hit it more than once if you draw it in a certain way. For example, something like this. Even on this graph, anywhere that you draw a vertical line, you only hit the function, you only hit the graph only once, never more than once. And in fact, right here, even if you draw a vertical line, this open dot means that there's not a point there, but there is a point here. So you really only hit the graph once. You hit right here, you don't hit anything right there. That's what that open circle represents. Even something like this, that has a big gap in it, even though there is not anything right here, the rule just says if you can go through the whole function and never hit more than one, go through the whole graph and never hit more than 1 point on the line, 1 point on the curve, it is a function. So even though there's a big hole right here, there's not a spot on this graph where I can draw a vertical line and hit the graph twice or more than once. So I say, yeah, this definitely is a function still, even though it's kind of a strange looking function that has a hole in it. Now, I said you don't want to be able to hit it twice, but you also might have something that, for example, this, of course, is not a function because I can draw a line right there and hit the graph 6 times. So anything more than once, we would put it into not, we put it in the category of not being a function. Anywhere we can draw a vertical line. Now, I have to be careful because there are some, you could draw a function that looks something like this. Or actually, I should say this is not a function, but you could draw a graph that looks something like this. In most places on the graph, you can draw a vertical line and only hit the graph once. But for example, right here, you draw a line and hit it 3 times. So if there's even one spot on the graph where you hit it more than once by drawing a vertical line, it's automatically not a function.